Hi everybody, welcome once again, and in today's video I'm going to explain you the concept of indifference curve and its properties. So indifference curve, as the name itself suggests, shows that the consumer is indifferent among all the available combinations. So it is a graphical representation of various combination of two goods. Here we have assumed that the consumer is consuming only two goods that offer the same level of satisfaction to the consumer. So let's understand this. Let's say that these are the alternative combinations of a good which are available to the consumer, good X and good Y. So if we plot these in the form of a diagram, we find that the consumer will be indifferent. That means all these combinations will be offering him same level of satisfaction. So here if we plot these points in the form of a graph, let's see what will be the shape of our indifference curve. Starting from this point, good Y, the first combination A, where we have 5 units of good Y and 1 unit of good X, then 10 and 2, it's like 10 units here of Y and 2 units of good X. And then next is like 3 and 6, where we have like 3 units of X, 6 of Y. Then 4 and 3, combination of 4 and 3, and then combination of 5 and 1. It will be somewhere here. So if we join all these points together, we'll get a shape which is convex to the origin, and this is our indifference curve. So the shape of indifference curve, please remember, is convex to the origin. This could be asked in the form of a question as well. And now what is the reason behind this shape? The reason behind this shape is the slope of indifference curve, and the slope of indifference curve is represented as marginal rate of substitution. So first we need to understand what is the meaning of marginal rate of substitution. So marginal rate of substitution is the rate at which units of a good are sacrificed to gain additional units of other good. Now in this case, as we can see, that units of good Y are sacrificed to gain additional units of good X. So we can represent marginal rate of substitution as delta Y upon delta X, that is loss of good Y upon gain of good X. This is marginal rate of substitution. Here we can find out the values of marginal rate of substitution, and I'm writing it here, marginal rate of substitution XY. So whichever good we are sacrificing is always written in the last. So if you are sacrificing units of good Y, that means you will write Y after X. So here, as we can see, that in the first case there is no sacrifice of Y. Then how many units are sacrificed? 5. So 5 units are sacrificed to gain one additional unit of X. Then how many units are sacrificed? 4, 10 and 6. That means 4 units are sacrificed to gain additional unit of X. Then 3 units are sacrificed, and then 2 units are sacrificed to gain one additional unit of X. So the rate at which these units are sacrificed to gain additional unit of the other good is basically marginal rate of substitution. And because marginal rate of substitution diminishes as the consumer increases consumption of the other good, therefore this shape is convex. So please remember here that the convex shape is because of diminishing MRS. In case MRS would have been increasing, then the shape won't be diminishing, the shape won't be convex, in fact it would be concave. But the realistic shape here is convex. So marginal rate of substitution, because it is diminishing with each additional unit, the rate at which one good is sacrificed to gain additional units of another good falls. So therefore the shape here will be convex shaped indifference curve is what we get because of diminishing marginal rate of substitution. Now the question here is that why marginal rate of substitution diminishes along the indifference curve. The reason behind this is law of diminishing marginal utility. So we have done this law earlier. So according to this law, as the consumer will consume additional units of one good, his satisfaction from that good will fall. So let's say that the current consumption at this combination A, he is consuming 1 unit of good X and 5 units of good Y. So if he plans to increase his consumption of good X, definitely he needs to decrease consumption of good Y, and in fact, but at the same time, as he increases consumption of X, the marginal utility for X will also diminish according to the law of diminishing marginal utility. So let's say that initially the consumer was willing to sacrifice, let's say, 3 units of Y. When he consumed third unit, now since because of this law, the utility from good X will decrease further, and he needs to have a combination of both the goods, so he will be willing to sacrifice less number of units of good Y than before. Here are the properties or characteristics of indifference curve. The first property or characteristic is indifference curve slopes downwards. The reason behind this is that since the consumer is consuming both the goods at all the combinations, he is consuming both good Y and good X. So in order to increase consumption of one good, he needs to sacrifice some units of other goods. So therefore, indifference curve is downward sloping. Next is indifference curve is convex to the origin. This we have done earlier. The reason for convex shaped indifference curve is diminishing marginal rate of substitution. So you need to remember this. The third property is higher indifference curve offers higher level of satisfaction. So if we have more than one indifference curve here in this diagram, we can label it as IC and IC1. So higher indifference curve, any combination of goods which lie on IC1 will offer more satisfaction as compared to any combination of goods which lie on lower indifference curve IC. So in the given case, let's say that there are two different combinations, combination A and combination B. Now combination B offers OM amount of good Y and let's say ON units of good X. Similarly at point A, the consumer is consuming OM units of Y and let's name it as OH units of X. So according to monotonic preferences, a consumer will always try to maximize his satisfaction. So as he consumes a combination here, like on IC1 combination A, his total satisfaction will increase because he is able to consume more number of units of good X, though the number of units of good Y OM here remains same. So since at this point B, he is able to consume these many units of X and OM units of at point B, he is able to consume ON units of X and OM units of Y, and at this combination he is consuming OH units of X and same number of units of Y. Since point A, which lies on a higher indifference curve IC1, offers him more number of units of good X and there is no change in his consumption of good Y, his overall satisfaction will be higher on a point which lies on a higher indifference curve. So the next property is two indifference curves never intersect each other, but in this diagram I have shown two different indifference curves, IC and IC1, intersecting each other. Now we'll see that what will happen if the indifference curves intersect each other and why they cannot. So if you look at this point, this is a common point for IC and IC1. So we can say that combination A and B, because any 2 points which lies on the same indifference curve will offer the same level of satisfaction to the consumer. So this means that point combination A and B will offer the same level of satisfaction to the consumer. Similarly, combination A and C again lies on the same indifference curve. They will offer the same level of satisfaction to the consumer. Now this cannot be possible because we have seen that two indifference curves cannot offer the same level of satisfaction. So if they intersect each other, it means that there is a possibility that these combinations which lie on two different indifference curves can offer the consumer same level of satisfaction. So technically this is wrong, and therefore it's not possible for two indifference curves to intersect each other. There is one more property here, that indifference curves cannot intersect or touch x-axis or y-axis. Now this is the fifth characteristic or property, that indifference curve cannot touch either of the axes, since it is assumed that the consumer is consuming two goods. Therefore, it's not possible that the indifference curve can touch either of the axes. And please remember that when we draw more than one indifference curve in the same diagram, it is termed as indifference map. So let's say we have one more indifference curve here, or more than one indifference curve is drawn in the same diagram. It is termed as indifference map, where each indifference curve shows a different level of satisfaction, and higher indifference curve, any point which lies on a higher indifference curve, will always offer more satisfaction as compared to all other indifference curves.